All right, now we're on to visualizing relationships, also known as multivariate analysis. So let's go through a few different scenarios. Let's say you have a numerical and a categorical variable, and you want to figure out their relationship. One way you can do this is a side-by-side box plot, where you measure percentiles that describe a distribution. This is also really helpful for identifying outliers. You could also use a density plot, just like what we did previously with our univariate analysis. This is going to be similar to a box plot, but it's a little bit better at showing overlaps. So here, we're plotting this body mass versus density. There we go. We also have our species in here as the categorical variable. You can also analyze two categorical variables. So here we have stacked bar plots. Geom bar is our geometry argument for, or our geometry function for bar plots. Geom bar with a position of fill is going to do the same thing. These are both stacked, but geom bar is going to make it so that all of the bars have equal heights. And don't worry, we'll go over this in the code. If there's two numerical variables, you're going to want to use a scatter plot, like we've had a few different examples already. And with 3 or more variables, that's where you're going to want to map to additional aesthetics. So you have your X and Y that determines your basic shape. Is it going to be something like a density plot, stacked bar plot, scatter plot? And then if you want to also add in there the category of species or something like that, or island, for example, that's when you add in different layers. Then facet wrap is also a great option for categorical variables. So here we've broken up the same graph across different facets based on island. So in this example, it's a little confusing. We have species by color, island by shape, whereas here, okay, I can see the individual species based on, again, color and shape combined, but these islands each have their own graph. So let's go through that in our code. Here, again, a numerical and categorical variable. We have ggplot. Side by side, we have our species. So these are categories. The species are individual categories, but body mass is numerical, so we can show their distribution within each species category. This also shows that the Gen 2 or Gen 2, not sure how to say it, by far the largest. The other two are smaller, but chin strap is the most densely packed around the middle with a few outliers. We can do a density plot. So here shows us similar information, just a different way. Here we see the same thing, how Gen 2 has the highest body mass and how chin strap is more narrowly defined around a median value. You can also play with the line thickness with our density plots. So here we've said ggplot, we've put in our data, we've mapped our aesthetics to be body mass and color representing species. If you want to play with different line shapes for this density, the argument is line width. So this right here is at 0.75. I can make it thinner at 0.5, or I can make it even thicker at 1. There's not necessarily a right or wrong, just what seems to get the story across the best. Now you can also fill in the area under the curves. This is the second example that we saw in the slides. For this, the argument is alpha, so alpha represents transparency. The first setting is just at 0.5, kind of the generic, what you start off with. You can make it less opaque by setting this to 0.25 if you just don't want that color to be as bold, or 0.75 if you want it to be even more bold. Again, I'm not going to tell you a right or wrong value. There isn't one. It's all about aesthetic preferences. Let's say I want to adjust both line width and undercurve transparency. I can do that here. Geom density, I've just added in multiple arguments, and I've also put in the colorblind scale just to make that easier for folks. So here we see not quite as aesthetically pleasing, but still easier to read where the different distributions overlap, and we've made those lines thicker. Now, let's say we have two categorical variables that we want to plot against each other. Here is where we're going to be using bar charts. If it's categorical, bar charts are our friend. First is our stacked bar charts. So here, just the basic way to do this, we're going to say that our fill is by species. So our X is island in this case. Our bar chart is automatically going to be count. And then our fill, if we want to divide it up into the individual species, is the argument there at the global level. We say geom bar, and here's what we get. So we can see that Biscoe has over 150 penguins. The bulk of them are the Gen 2. We see that Adelie is the only one that is across all 3 different islands. If you want all the heights to be the same, that's when you say position equals fill. You put position, the position argument set to fill in your geom bar layer. Here it shows us the same information. It's just a proportion as opposed to an actual count. So our first one, we can see, okay, there's over 150 penguins on Biscoe Island. There's about 125 on Dream. If we do position equals fill, then we can see more of the proportion. So about 75% of those islands on Biscoe are Gen 2. It's closer to 50-50 between Chinstrap and Adelie on Dream, and then Torgerson Island is 100% Adelie. Let's say we have 2 numerical variables. So here we have flipper length and body mass, our friend that we've been using quite a while. Here we've already seen this example, but our basic geom point, and like I said, I almost always add in a line of best fit because it makes it a lot easier to see exactly what the trend is. Now if there's 3 or more variables, that's where we add in extra layers. So in this case we have ggplot. We say, okay, I'm using our penguins data. My aesthetics, X is flipper length, Y is body mass. Our geom point, we're mapping our aesthetics such that color is going to indicate species and shape is going to indicate island. So I've added in the 3rd and 4th variables in as color and shape right here. Or like I showed you in the slides, we can do this via facet. Now when you want to use a facet wrap, what you do, same thing, X and Y, flipper and body mass. Our geom point, we're going to have species and shape, or we're going to have color and shape both represent species. I tend to think that having color and shape represent different things can be a bit confusing, a bit hard to read. And then for facet wrap, I just put the tilde and the variable that I want to plot in the individual facets. So here, those individual facets represent our islands, and here we go. Now again, it looks a little crammed down in our RStudio window. It's a lot prettier when we click on export or zoom. So here we go, that's that graph there. Now I'm also going to go through a few exercises. So in section 1.5.5, I'm going over exercise 2 where it asks you to plot highway versus display with a 3rd numerical variable. So this is our MPG data, question mark MPG gives you all of the data information. I'm going to pipe, say MPG, then ggplot, X is display, highway is Y. My geom point, I'm going to make the color and shape both represent class. I'm using geom point because our X and Y are both numerical, class is categorical, so we'll represent that with shape and class, shape and color, excuse me. Then geom smooth, like I said, that's just my habit, I always add that in, and I'm making some labels so that way we know what's going on. So here we go. Here we see the shape and the color, but here we see that SUV isn't actually shown, and that's because if you use shape, there's only 6 shapes available. So instead we're just going to do color so that way SUV doesn't get left out of the show. So SUV isn't plotted, let's just do color. Same exact thing, geom point because it's numerical. Class is categorical, so just color. Same titles and everything. There we go. Now SUV has that pink color. And same here, I'm going to do the same exact thing, but the color blindness palette, just to make it a little bit more friendly for those with color blindness. All right, that's it for this video.